Our learning target for today is I can use meters to model the decomposition of one whole into hundredths. So we're going to represent and count hundredths today. That's our learning target, our goal for today. So first we have to remember all the way to the beginning of the year, 1 meter is equal to 100 centimeters. That's the metric length we're going to be working with today. So yesterday we were working in the tenths place to the right of our decimal point. Now we're going to move to the next place value over that's 10 times smaller to the hundredths place. And that means that we would write it in decimal form. We have our whole number, our decimal point, our tenths place, which for right now is a 0. So 1/100th, we would have a 1 in the hundredths place, in the second place value to the right of the decimal point. Now, we have two strategies we can use to show our place value. I've drawn two tape diagrams, and we'll see there's 10 spaces in this first tape diagram, and each of these spaces, just like yesterday, represents 1/10. Now, if we broke or decomposed each of these 10 parts into even smaller parts, and there were 10 smaller parts in each of our tenths, we would have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We would have 100 total parts. That would be our denominator. And our numerator, if we had the first shaded in, we would have 10 shaded in. That means we would have 10 100ths. And we can see that 10 100ths takes up the same amount of space as 1/10. So our parts are the same. They're actually equivalent fractions, 1/10 and 10 hundredths. So I'm going to erase the second tape diagram. That's one strategy we're going to use today. And I'm going to look at 2/10 of a meter plus 5/100ths of a meter. So what would our answer be if we were adding 2/10 of a meter plus 5/100ths of a meter? Well, I know from before that each of these 10 represents 1/10 of a meter. So I'm going to shade in that 1/10 and a second tenth. And now again, I can decompose because I know that each of these 10, if I decompose each of these 10, 10 times 10, I'll have 100 smaller parts. So I'm going to go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, and I have 10 now. So I have 10 smaller pieces, and I'm going to look. I have 5/100ths. So I'm going to shade in 5 of them. 1, 2, 3, 4, and 5. And so now how many do I have altogether? Well, if I turn these into hundredths, because I'm going to go with the smaller place value, I'm going to decompose so that I'm working in the smaller place value. I have 10 hundredths here plus 10 more hundredths plus 5/100ths, which we represented by decomposing that third part. And now my job becomes a little bit easier, right? Because I know when I'm adding fractions, my denominator is going to stay the same. So I'm still working in hundredths. That's still going to be the total amount of parts I have. And now I can just add my numerators. 10 plus 10 is 20, plus 5 is 25. So I have 25/100ths. And I can break this apart using the second strategy. So we use the tape diagram, and we're going to go back to our number bond, just like we were using with fractions. I'm going to break apart this fraction. So I have 25/100ths. Well, if I have 25/100ths, I'm going to put that down for a second, and I'm going to bring my place value chart back up. 25/100ths. Well, I still have my decimal point. I have a 0. How many tenths do I have in 25/100ths? Well, we had 2/10, right? That's what we started by adding. We added those 2/10, and we have 5/100ths. So in decimal form, we would write it as 0.25. So knowing that, I have 0.2 in my tenths place. So I would write 0.2 as my first part of my number bond. And the second part of my number bond would be point, I'm going to put a 0 there just to show that I have 0 ones, would be 0.05. We have to place a 0 in the place in our tenths place because we still have to have a digit in that place value. It's like when we're writing 501. We can't skip the 0 in the tens place or else we would end up with 51. It's the same thinking, same place value thinking when writing out decimals. We need to show that 0 in the tenths place so that we can see that we have our 5 in the hundredths place. So today, like our goal said, is we're going to represent and count hundredths. So we have the tape diagram to do that. We have the place value chart, and we have a number bond. So if I were to write 28 hundredths on my whiteboard, I need to think, how can I break this apart to show how many tenths I have, or how many, and how many hundredths I have. So I can use the number bond, or I can draw it out with a tape diagram, or I can model it with the place value chart. There's 3 different strategies that we can use. So actually I'll start with the number bond. I have 2 in my tenths place. So if I have 28 hundredths, I know there's a decimal point right there. I have 2 in my tenths place, so I'm going to have 0.2. And I have 8 in my hundredths place, so I need to make sure again I'm representing each place value. Or I can come over to I can draw my place value chart. I know that with 28 hundredths, that's less than 1. So I have my 0 in my ones place and my decimal point. Again, in my tenths place, I have a 2. And in my hundredths place, I have an 8. So in decimal form, it would be 0.28. So 2 choices there. We can either use our place value chart, or we can use our number bond. And we can start from the smallest place value chart, just like we did when we were writing whole numbers, placing that 8. Okay, we have 8 tenths, or 8 hundredths, and then, I have 8 tenths, and I can place that in. And then working our way back, we have 0 ones. So there will be 2 problems written just like this on the next slide for you to solve either using the number bond, tape diagram, or the place value chart. I suggest you do 2 for each. 2 of those 3 strategies for each to check your work.